So looking back at our situation, here's our 4 constraints, right? In your packet. So going here, who can make sense of this first bullet point for me? What's going on there? What is T? Why is it less than or equal to 20? Zeph, what's going on?
So T is the cost of the tickets, because in our information, the ticket price can't exceed $20.
Yes, I'm going to write ticket price. Same thing you said, right? And in the situation, tickets can be $20, but nothing more.
Yeah.
20 works though, right?
Yeah.
Whereas if it said tickets had to be less than 20, what would be different?
There wouldn't be a
Then there would be a line.
Straight up less than symbol then. Okay, great. What about P? We got T, now we need P. Who's got an idea for me other than Zeph? What does P stand for, Ryan?
How many people are going to come in between us? So it's either going to be 120 or 200 people.
Yeah, people coming to the ball, the number of people, right? They said last year there's 120, they expect more, but up to 200. So does 200 work? Yes, and so does everything in between, except not fractions or decimals, because even if someone was like missing a limb, still a whole person. This third one, we got a PT and an M. We already know that PT means the number of people times the ticket price, right? We already established T and P. Meredith, what does M have to be then? You don't know? Okay. Who's got something for M? What is M? There are meals. So we're making money by selling tickets, and then what are they paying for? Yeah, Sophia?
Meal price.
Yeah, M is going to stand for meals and entertainment price, right? Because they needed to make at least $200 profit, right? So the money coming in is people times the ticket price. I'm going to take away the meals and entertainment, and that needs to be at least $200. $300 work? Yeah. $201 work? Yeah. $199? No. Cancel the whole thing. Maybe they could just find 10 cans on the side of the road and make it happen. I don't know. But last one, Cam, what you got?
I did not do that one.
Well, let's look at it. What would there's people divided by 20. What circumstance would we divide all the people by 20 there?
I have no clue.
Ava?
Chaperone?
Yeah, C is chaperones. That's
pretty cool.
and they need one chaperone. So this right here, that's like the same thing as a 1/20th P. So 1/20th times the number of people will tell you how many chaperones need to show up to watch these children roll around at this ball. Okay? Next up, we're going to talk about the skyscraper. Okay? It holds at most 15 folks. Each car can carry up to 1,500 kilos. On an average, just so you know, an adult's about 70 kilos and the kid's about 35 kilos. And we're going to assume that each person is bringing 4 kilograms of stuff with them. Maybe it's a puppy. Maybe it's their bike. Maybe it's groceries. Maybe it's one single JoJo Siwa hair bow. Either way, it's 4 kilos, okay? What you need to do as a table is make up as many equations and inequality constraints as you can think of in 5 minutes. Let's make it happen. The sky is the limit. All right, friends. I'm looking for as many inequalities as we can get here. So let me get us some space here.
Like this.
Okay. So, who's got one equation or inequality I could use? Livia, give me one.
A plus C is less than or equal to 15.
The number of children and adults together. Also, I could think of something like the people need to be less than or equal to 15. Yours is great. I'm just showing like an equivalent that is different. What about this? I also came up with some equations. Adults are 70 kilograms and children are 35. There's some equations. Okay, what else do we have? What's another inequality or equation we could get? Ryan?
So I'm not sure if this would be right, but it is 15 times 39 through 74 is equal to or less than 1,500.
Okay, here's what I'm hearing. Something like 74 per adult plus 39 per child needs to be less than or equal to 1,500. Something like, I also saw one today that was like 70A plus 35C plus 4 times A plus C needs to be less than or equal to 1,500. I like that one.
That's pretty crazy.
It's the same thing. These are the same, right? Zeph, what were you thinking?
Oh, well, that you just wrote down.
Okay, I also saw it like this, Zeph. 70A plus 4A plus 35C plus 4C, and these be less than or equal to 1500. So,
That's just making it harder.
no, different.
It sounds like.
I was trying to do something like that.
Yeah, Josiah?
Well, another like one to that one I
Yeah.
did like adults plus children equals P, which is the total amount of people. And then
Adults
I
plus
did-
children equal people, okay.
Yeah, and then I did 70A plus 35C plus 4B.
Oh, okay, 70A plus 35C plus 4P needs to be less than or equal to 1500. Not 15,000, 1500. Okay, yeah, I like that, Josiah. So there are different ways that we represent the same thing. Either way, we're taking a situation and making it into these inequality constraints, right? So who can give me some answers to number 1? Kim?
I had the 2.
Y, yeah, Y can be 2. Good job.
No.
Okay, who else has an answer to number 1 for me that works? Something else for number 1.
Oh,
Ava?
9.2.
9.2 does work because it can be less than or equal to. JP?
Y equals 5.55.
5.55. I'm going to go 5 and 5 ninths. Almost the same number. What about, here's a fun one. I just got to throw it on there. Pi works.
Yeah.
Meredith?
Why can we 9.2
Yeah, so for number 1, are you guys seeing all these infinite answers? So 7, 8, 9, 10, let's say. 9 does 9.2 work?
Yeah.
So I can put a solid dot there. The solid dot, remember, says it works. And so does everything to the left of it. Forever. All of it. Okay, now looking at number 2. Who's got some answers for me? Looking at number 2. Zeph, give me one answer.
X is greater than 1, so that could be 3.
X can be 3?
No.
No. Because that would be 3 times 3. 3 minus 3.
Oh, Zeph, I know what you're thinking. You're thinking whatever's in here could be 3. But 3 minus 3 would give me 0.
Oh, yeah.
One word, 1 doesn't work either.
If the solve the correct.
Hey, that's an awesome mistake. That's a great mistake. Kyle, you got an idea?
Like -1.
-1? Okay, so 3 plus 1 is 4 times 7. That works. Who's got another one that works for me? Okay, Cam.
Let's go. Okay. I got 0.9.
So 1 would give me 4. It's a little less than 1. So yeah, a little more than 7 times 2. Cool. Meredith,
That's be anything under 1.
anything less than 1, you think?
Yeah. I agree.
So pick a number.
Why not? Why not?
0.3. Okay. So there is a way to math this. Let's do it. All right, Ryan, you ready?
Negative.
So the first thing I would do to solve for this. So a lot of you distribute here. I'm going to choose to divide by 7. We got 3 minus x is greater than 2. Distributing works. The next thing I would do to get x alone is subtract 3 from both sides. So here's a negative x and a negative 1. I'm going to divide both sides by negative 1 and get x and a 1. Now, last year, when you decided what symbol you needed, you went to your original and you substituted in a 0 to see if it was true. So if I put a 0 in here, is 7 times 3 greater than 14? It is. So 0 works. 0 works for x, right? Because this is an equivalent inequality. So if 0 works, does x have to be less than or greater than 1? If 0 works, x has to be less than. Now, what do you notice happened to my symbol?
It went the other way.
It went the other way. And let's get into why.
And there's no equal. Does it always have to go the other way? Or does
Nope.
it have 3 minus
I'm going to give you
14
why,
times
if you'd listen.
That's why it's equal 14 because there's no line, right?
It's because on a number line, if 0 is in the middle, and let's say I have a 2 and a negative 2, if I were to multiply or divide these numbers by a negative, the positive becomes negative, and the negative becomes positive.
It's a very interesting.
So if you multiply or divide by a negative, the relationship of what's big and what's small changes to the opposite. Therefore, we flip the sign. So I don't do the test 0 thing. I know if I multiply or divide by a negative, I flip the sign because it changes what's big and what's small, because positive becomes negative, negative becomes positive. And like a small negative is bigger than a big negative. Now, Another thing to think about with this is, if I add to two things, they both get that much bigger. If I subtract from two things, they both get that much smaller. If I multiply two things by a positive number, they both get that many times bigger. If I divide two things by a number, they get that many times smaller. But when I multiply or divide by a negative, it changes the relationship between big and small because of the positives and negatives. All right? It's all because of the number line. So flip the symbol. And this one sticks out to me. Set this one up. You're in college. You need a job, part-time job to help pay tuition. And you need to pick between these two jobs. You're not picking by passion. You're picking by which one's going to make you the most cheddar. Okay? So you got a job offer at the hotel. It's $18 an hour, and they're giving you $33 a month bonus for transportation. So that's for like your driving, your bus, your Uber, whatever it is.
It's just a one-time thing.
At once a month, you get 33 extra bucks for transportation. Or you could work at this restaurant as a server. You make $7.50 an hour, and then you get tips. Your tips, the restaurant only has 4 servers. They average $50 in tips an hour, and you split it up evenly 4 ways. All right. Start by figuring out which one's the better deal. We are going to start by finding when they are the same money made. So this equation up here is our two situations. We've got wait and tables, $7.50 an hour plus 50 divided by 4 per hour for tips. And we've got $18 an hour plus $33 travel budget. All right? And you're going to figure out how many hours worked would you make the same money between these two jobs. All right. So when we look at this equation, the first thing I'm going to do is I'm going to combine my like terms. I'm going to have $7.50 an hour plus $12.50 an hour for 18. No, that's 20.
It was 18 an hour.
20 an hour.
So does this mean
So the other situation is 18 an hour plus $33 travel budget, essentially. Okay, so everybody good with where I'm at? So to figure out how many hours these two things are equal, I'm going to subtract 18 hours from both sides. And this makes sense. The $33 travel budget needs to equal the $2 per hour difference when they're the same, right? So if I divide it by 2, the number of hours that they'll have the same wage is 16 and a half hours. If this is 16 and a half, I'm going to have to call this 17 and 16, 17.5, so on, 15.5, so on. So does everybody go with how I got the number of hours that'd be the same? So if you're only going to work 16 and a half hours a month, pick your passion. But what happens if you're going to work less than 16 and a half hours? Which job should we choose and why?
Hotel.
Ryan, why are you saying hotel?
Because up until that point, with the plus 33, it's.
Yeah. I actually want to work at the hotel for 1 minute a month. Get that $33 bonus. Who cares what you get for the hour? Then you go work at the restaurant.
well,
I'm just
Work at the
joking.
restaurant for the rest
So-
of the day.
That's ingenious.
So you're only getting 18, you're getting less per hour, but you're starting 33 ahead here, right?
But they would honestly
Now,
fight.
so if you're less than 16 and a half hours a month, you should choose the hotel. Now, if you're going to work more than 16 and a half hours a month, you make more per hour waiting tables, you should pick waiting tables, right? What is the difference for these working out like that? What's the number you can point to? Or the two numbers you
you
can
got
point to?
plus 33.
Well, the plus 33 means that starts as the better deal, but why does waiting tables catch up?
Because it has $2 more per hour.
You end up with $2 more an hour. So that dollars per hour in a line, what is that called? Some people might call it the rate that it changes.
The rate change.
The slope. This number right here is the slope, and it's the reason. Also, this number right here is the y-intercept, which is also part of the reason, right? But once we find out that they're equal, we can find out this one's better if we work more, this one's better if we work less, based on the slope.